Okay, 11.3. So we did percents and we did ratios and proportions, okay? So with that goes something called direct and inverse variation. We already did direct variation back in chapter 4. And direct variation just is saying that if x and y vary directly, then we can write an equation that says y equals k times x for all x and y in the relationship, okay? K is the constant of variation. And then to find k, k would equal y divided by x for all x and y in your relationship. And k can't equal 0 because if it does, then every x value gives you a 0 y value. And direct variation is linear. So when you graph it, it looks something like this. And it always passes through the point 0, 0 for direct variation. Okay? Then you have inverse variation. And what inverse variation is it says that x and y vary inversely for a constant k if x times y equals k. So the product of all x and y equals the constant in inverse variation. So then when you go to write your equation, you get y equals k divided by x. And in inverse variation, the constant can't equal 0 and x cannot equal 0. Because if you divide by x, or if you divide by 0, you get an undefined value. Okay? This isn't in your note. Well, the graph for inverse variation then is going to be a curve. It's not going to touch the y-axis and it's not going to touch the x-axis, because if it touches the x-axis it means x equals 0, which it can't, and y is never going to equal 0 because you always get a number divided by a number. So it'll come close, but it won't ever touch. Okay? And again, k is your constant of variation. Right? So again, in direct variation, x and y can equal 0, but in inverse variation, x and y cannot be 0 ever. So you get this curve to your graph. So you can use that information then to write an equation that relates your two variables. So when x is 3, y is 12. And then if we're told x varies directly with y, then you're going to be able to say, okay, well, x varies directly with y, so we know that y equals k times x. So we know that k equals y divided by x. So that's the first thing you're going to do, is you're going to find your value for k. And we're going to say, okay, it's direct variation. So we're finding k, which is y divided by x. So 12 divided by 3, which gives us 4. Okay? But then you want your equation. This just gives you what k is. So then to get your equation, you go back and take your value for k and plug it in, and then we can say y equals 4x, because it's direct variation. So we found k, and then we plugged it in for k in our direct variation model, and we get our equation. We can do the same thing if you know it's inverse variation. Right? So if x varies inversely with y, then you know y equals k over x, so k equals x times y. So again, we're going to find k first. So k equals 12 times 3, which is 36. But it's inverse variation now. So y equals 36 over x will give us our equation for the model because it's inverse variation. Okay, so we get our two equations there. Depending on what kind of variation it is. So the steps are the same. Find k, then write your equation, but you find k depending on if it's inverse or direct variation. Okay, so we want to use those two models then to compare them for different x values. So we have our first one said y equals 4x, and our second one said y equals 36 over x. And we're going to use x equals 1, 2, 3, and 4. On both of our models. Okay, so in the first one, if x is 1, then y is 4, because we get 4 times 1. If x is 2, y is 8. If x is 3, y is 12. And if x is 4, y is 16. Okay? If I were to graph this, here's our coordinate plane. I'm going to count by 4s for space, so 4, 8, 12, 16, and then these are just ones, okay? It is linear, and it's increasing by 4 every time. So our graph will look like this, okay? Then, for inverse variation, if x was 1, y is 36, because 36 over 1. If x is 2, we get 36 over 2, which is 18. 36 over 3 is 12. And 36 over 4 is 9. Okay, so if we were to make our graph, we have 36 up here. Half of that is 18. Then 9, so the graph will have a curve like this. Okay, so both direct and inverse variation represent functions, except for with inverse variation you cannot put in 0 for x. Okay, so that's our inverse and direct variation models.